Hi everyone, my name is Boyang Shao and this is my demonstration for the first assignment for E542. My USC ID and my email are here. So there are three topics in the first assignment. The first one is the Linux virtual machine setup, and the second one is the client router client virtual networks emulations, and the third one is the socket programming. For the first part of this assignment, we set up a Linux virtual machine, and the configuration for this virtual machine are listed here. If we open it up in the VirtualBox GUI, we can see that this one is the virtual machine we are gonna use. And if we open up the settings diagram, we can see that the CPU is set to be 1 core and the memory is 2 gigabyte, and for the storage is about 50 gigabyte, and the Linux version we use the Ubuntu 16.04 because it's very stable. The second part of this assignment is the client router client networks. We have to simulate this kind of networks model. And the very first step for this part is to clone the virtual machines we just installed into 3 copies. And you can see from the VirtualBox manager, I have already cloned the VirtualBox we just installed into 3 copies, which I named them the router 1, the PC 1, and the PC 2, and I grouped them as a new group, and I renamed the new group as the emulated networks. So for the second step for this part is that we set up the network adapters for each copy of these virtual machines. So for example, we take the router 1 as an example, and we open up the settings diagram, and we find the network page. So there are 2 things we have to do in the network setup. The first one is that we have to enable the internal network for this virtual machine, and we enable this one, and then we attach it to the internal network, and we name the internal network as the internet 1. And this is the step we use to make them able to communicate with each other for these 3 copies of this virtual machines. And the second thing we have to do is to add a rule which its name is the SSH, and we use the SSH to make them can be accessed by the host machine. And we name this rule SSH, and the host port is the 14601, and the guest port is 22. And we just do the same things for the PC1 and PC2, and the mild difference for the 3 of them is that in the SSH rule, they use the different host port numbers. For PC1, it used the 14501, and for PC2 it used the 14502, and then we set up the virtual machines networks. And then we have to access to the 3 virtual machines from our host machine, which is an Windows 11 through the SSH. So before we access to the virtual machines, we have to open up the SSH on the virtual machines first. So take one of the virtual machine as an example, like this one, and we first of all we input the command enable SSH, and then we start the SSH. And we can say that we can access to this virtual machine through the SSH, and we do the same things for the rest of them, and then their SSH are all on, and then we can get back to our host machine, and we open up 3 terminal windows on our host machines. And to get access to the virtual machines, we can use this command. This input is the username for the virtual machine, and this one is the port number for our virtual machines. For example, if we want to access to the router 1, I remember the port number is 14601, and the IP address is the local host, because the virtual machines are all on the local machines. So we input this command, And we can see that it asks for the virtual machine's password, input it, and then we can access to the virtual machines through our host machines. And we do the same thing for the rest of the terminals. This one is for the PC1 and port number is the 14501. And we input the password, and down this terminal is for the virtual machine PC1, and this is for PC2. The port number is 14502. Password, and down we use the 3 terminals to access to the 3 virtual machines through the SSH. And the last step for this part is to configure the virtual machines to be PC1, PC2, and routers, and we use the Quagga scripts. So we get back to the terminals, and we can. The first thing we have to do is that we enter the root of this virtual machines. We use this command, and also the password, and then we are at the root of the virtual machine, and we input the Quagga scripts for the virtual machine. We have already copied the script in this text file, and now we are configuring the router 1 virtual machine, and the scripts for the router 1 is here. Copy them here, and we enter it. And boom, we have already configured it to be the router 1. And also for the router for the PC1, we enter the root, the password, okay, and the scripts for the PC1 is here. We copy it, we enter, and boom. And also for the PC2, but there's one thing I have to mention is that we have to change mildly from the scripts of PC1 to PC2. The first thing is that the name is PC2 but not PC1, and also the IP address, we can see that it ends up with the 1.1, but the PC2 ends up with the 2.1. So we have to use the different IP address for PC1 and PC2. So we copy the script for PC2 and enter, and then we have configured these three machines to be router 1, PC1, and PC2, and we can make them to communicate and to form the model for client router and the client networks model. And the third part of this assignment is the very famous socket programming. And to demonstrate this part, I want to use the README file, which I have already uploaded in my GitHub homepage. And let's move to here. The first thing I have to mention is that my development environment is I use the Ubuntu version 16.04, and the compiler I choose the G++ version 5.4.0. And the assignment files structure for this part is we have a README file, markdown file, the make file which can automatically compile all of the source codes, and we have also the client.c codes and server.c codes, which are the implementations for the client and server under the TCP/IP protocols. And we also got the same one, the client and server codes under the UDP/IP protocols. So in the following section, I will show you how to compile and run off the source codes of the client and servers. So the first thing is to compile off the codes, because I have already made a makefile commands, and we can use only one single line of the command make all to compile all of the source codes. And let's try this in our virtual machine. Close all the terminals, and we open up a new terminal under the root folder, and we input the command make all. And we can see that all the four source codes are compiled at once, and we got the four output codes. And then I'll show you how to run the server and clients. So the first part is that we run the server and clients based on the protocol TCP/IP. So we know that if we want to use the TCP/IP, we have to launch the server first. So the command to launch a server is this. Let's try this in our virtual machine. We choose a port number for the server. Let's hope the 60,000 is not used. And the server is on. And then we can launch our client to connect to the server and also communicate with the server. And the command to launch the clients is shown as this line. So let's try this in our virtual machine. Let's open a new terminal window. This is the terminal for the client, the first client. First client, yeah, is the command like this. And we can see that there are two input with the command. First is the IP address. Because we launched the server and clients on the same machine, so we can use the local host as the IP address input. And also the port number, we have to use the same one as the server does. So we can connect to the same server on this IP address. So let's launch the client, and if we see this line, it shows that this client has already been connected to the server, and we can communicate with the server. So let's input a message to see what is happening. Let's say hello 1, and the server got the message from the client, and also the client got the response from the server. It said, I got your message, and the client will enter the next loop to wait for the more message input and send them to the server, and do it over and over again. And also we can see that the server also enters into a new round, and it will wait for more connections and also wait for the more messages from the connected clients. So let's send another new message from the client, hello 2, and the server got the message hello 2 and sent back the response to the client. And also the server can handle the more connections from the more clients. So let's launch the second client and see what is happening with the server and clients. Also, we use the same command to launch the second client. This here. And we can see that the second clients are also connected to the server, and we use the second client to send messages to the server. Say hello from client 2, and the server got the message from the client 2, and we get back to the first client. Also, we send a message from the client 1, and the server can got the message from both the client 2 and client 1. And we can also launch more clients. We can launch up to 5 clients to this server, because I set it to be 5. And we launch the third client. Also use the same command. The third client is also connected to the server, and we input the message hello from the client 3. And the server got the message from the client 3, and we can see that the server can handle the connections from 3 of the clients. And this is how the TCP/IP works. And if we want to close off the clients, we can just use the command Ctrl+C, and you can see that the client 3 is off. Client 2 is off, and the client 1 is off. And the server now has no connections from the client, and it can wait for more connections and more messages from the clients. And if we want to close the server, we can use just the same command, Ctrl+C, and the server is off. And this is how it works under the protocol TCP/IP. And then let's get into the UDP IP protocol. As we all know that the UDP protocol is a connectionless protocol, which means that we do not have to establish a connection between the server and the client and then communicate with the server or the client. We can just directly send a message from the server to the client and also send the message from the client to the server, and it received from the other end, and it just need no connections. So from this characteristic, we can tell that we can launch the server first, and we can also launch the client first. So let's launch the server first. The command to launch the server is this. Let's try this in our virtual machine. Let's close all the terminals. Got a new one. Okay. The server, we use the same port number 60,000, and the UDP server is on. And we also launch a client. Use the very similar code command. Also, the IP address is localhost, and the port number is 60,000. And let's go. The client is on, and we can send a message from the client to the server. Let's say hello, and the server got the message from the client, and the client got the response from the server. The server said, "Got your message." And we can also send a second message from the client, and also it got the hello too, and send back the response to the client. So we can technically we can launch as many as the clients as we like, because it's totally connectionless. So let's launch a second client. Also the same code for the client. We can use a random message from client 2, and the server got the message from the client 2, and we can launch the third, the fourth, the fifth, the 100th clients as we like. And the server will receive the messages from the clients one by one, and then send back the response to the clients. And this is how the UDP works. And if we want to close the clients and the servers, we use the same command, Control+C, and the client 2 is off, and the client 1 is off, and also the server is off. And this is all I want to show about the UDP IP protocol and how it works. So this is all the content for the part 3, the socket programming, and I have already uploaded the codes of this part onto the GitHub, and also I have uploaded to the Blackboard's submission page. So let's get back to the slides, and let's skip all the part 3 slides. And that is all I want to demonstrate about the assignment 1 for the E542. And thank you so much for watching my presentation. And if you have any concerns or suggestions, please just feel free to contact me at my email address here. And thank you so much, and have a good day.